Ever wondered how your computer knows where to find a website? Well, it's all thanks to something we call the Domain Name System, or DNS for short. This system plays a crucial role in our digital lives, acting as the internet's phone book, if you will. Every time you type a website name into your browser, DNS is hard at work behind the scenes. It's translating those human-friendly website names like google.com, comma, into something computers can understand. IP addresses. Imagine trying to find a house in a city without an address. It would be pretty difficult, right? Now, imagine the internet as that city, and the houses as websites. DNS provides the addresses, or IP addresses, for these websites, guiding your computer to the right destination. So, without DNS, you'd have to remember the IP address of every website you want to visit. Not so easy, right? Now that we know what DNS is, how does it work exactly? Imagine you're sitting at your computer, typing a URL into your browser. Let's say, for instance, you want to visit your favorite tech blog. The instant you hit enter, an intricate process begins. The browser doesn't understand the URL as it is. It needs an IP address. So it sends a request to a DNS server asking for the IP address that corresponds to the URL you've typed in. Think of the DNS server as a giant, constantly updated phone book. It looks up the name, finds the matching number, and sends it back to the browser. This IP address is the destination your browser needs to fetch the web page. In essence, the DNS server is the essential middleman, translating human-friendly URLs into machine-friendly IP addresses. This process might seem complex, but it happens in the blink of an eye, making your browsing experience smooth and seamless. But what happens when the DNS server doesn't have the IP address you're looking for? Well, this is where the concepts of recursive and iterative queries come into play. A recursive query is like a game of telephone. Your computer asks the DNS server for an IP address. If the server doesn't have the information, it asks another server, and so on, until the IP address is found. The last server in the chain then sends the information all the way back to your computer. On the other hand, an iterative query is more like a scavenger hunt. Your computer asks a DNS server for an IP address. If that server doesn't have the information, it simply directs your computer to another server to ask. This process continues until your computer finds the IP address itself. In both cases, the information is stored for future use, speeding up future queries. This system of queries ensures that even if a server doesn't have the information you're looking for, it can still find it and get you to your destination. In a world where online security is paramount, how does DNS contribute? Well, DNS, or Domain Name System, has been built with several security measures to protect against malicious activities. One of these is DNSSEC, a suite of extensions added to DNS to provide a layer of security. Just like a seal on a letter, DNSSEC authenticates the origin of the data and verifies its integrity as it journeys through the internet. It doesn't guard against all threats, but it does provide a shield against certain types of attacks like DNS spoofing, where bad actors try to redirect traffic to fraudulent websites. Other security features also include rate limiting, which helps in mitigating DNS amplification attacks. It's a cap on the number of responses from a DNS server to a single IP address within a certain time frame. With these security measures in place, DNS not only directs traffic, but also helps to keep the internet a safer place. So, we've learned quite a bit about DNS, haven't we? Let's take a moment to revisit some of the key points. At its core, DNS, or Domain Name System, is the internet's phone book. It's the tech magic that translates the website names we humans can remember into the IP addresses computers understand. It's a crucial part of how we navigate the vast digital ocean that is the internet. We've dived into how DNS queries work, both recursive and iterative, and how these processes help connect your device to the website you're trying to reach. And let's not forget about DNS security. It's a vital shield protecting us from the dark corners of the web, keeping our browsing experiences safe and sound. So, next time you're surfing the web, spare a thought for the invisible workhorse that is DNS. Remember, every time you visit a website, you have DNS to thank for a smooth and secure browsing experience.